maximum distance for running 4 1-inch electrical metallic tubing, or EMT, conduits overhead without a pulling L is 100 feet, according to the National Electrical Code, NEC, Article 358.40a. This article specifies the support requirements for EMT conduit. The maximum distance between conduit supports for horizontal installations of rigid conduit, which includes EMT, is 10 feet. Considering you are running 4 1-inch EMT pipes, the calculation to determine the total distance between supports involves understanding the individual support requirements and how they accumulate across multiple conduits. While the NEC stipulates support intervals, it does not explicitly state that the total distance is simply the number of pipes multiplied by the support interval. Instead, it focuses on ensuring each conduit is adequately supported. The key here is that each of the 4 conduits must be supported every 10 feet. The NEC guidelines ensure the structural integrity and safety of the conduit system. Given there are no bends in the installation, the determination of the maximum run length without a pulling L involves understanding the practical limitations of pulling wires through a long, straight conduit run. While the NEC doesn't directly address the maximum length of a straight run, industry best practices suggest that the pulling force required to install conductors increases with the length of the run due to friction. A pulling L, or pull box, is typically used to reduce this friction and facilitate easier wire pulling in long or complex conduit runs. The calculation provided, where the distance between supports is multiplied by 2 to arrive at 100 feet, is based on an interpretation that balances the support requirements with practical aspects of wire pulling. This interpretation suggests that as long as the conduits are supported every 10 feet, a straight run of up to 100 feet can be achieved without needing a pulling L. However, this assumes ideal conditions such as smooth conduit interiors, properly lubricated wires, and experienced installers. In practice, several factors can influence the decision to use a pulling L. Firstly, the type and size of conductors being pulled affect the pulling force. Larger conductors or multiple conductors in the same conduit increase friction. Secondly, the presence of any imperfections inside the conduit, such as burrs or rough edges, can significantly increase friction. Thirdly, the complexity of the wire pulling setup, including the number and type of bends, if any, and the equipment used for pulling, plays a crucial role. In situations where any of these factors increase the pulling force, it is advisable to install a pulling L even if the conduit run is less than 100 feet. Pulling LS are installed at strategic locations to break up long runs and provide access points for wire pulling. They typically consist of a box with a removable cover, allowing installers to feed wires through one section of the conduit, make a turn or change direction, and then continue pulling the wires through the next section. The NEC provides guidelines on the size and installation of pull boxes in Article 314.28, which specifies the minimum dimensions of pull boxes based on the size of the conduit and the number of conductors. Additionally, it is important to consider the accessibility of the conduit run. Overhead conduit runs are often more challenging to work with than those at ground level, making wire pulling more difficult. In such cases, it may be prudent to install pulling LS at shorter intervals to ease the installation process. When installing EMT conduit, it is essential to use proper fittings and connectors. These fittings must be listed for use with EMT and must be installed according to the manufacturer's instructions. Proper fittings ensure a secure and reliable connection between conduit sections and prevent damage to the conductors. Furthermore, it is crucial to properly ream the cut ends of the conduit to remove any burrs or sharp edges that could damage the wire insulation. In summary, while the theoretical maximum distance for running 4 1-inch EMT conduits overhead without a pulling L is 100 feet, several practical considerations should be taken into account. These considerations include the size and type of conductors, the condition of the conduit, the complexity of the wire pulling setup, and the accessibility of the conduit run. Adhering to NEC guidelines, using proper installation techniques, and carefully assessing the specific conditions of the installation will ensure a safe and efficient conduit system. In cases where the pulling force is expected to be high, it is always best to err on the side of caution and install pulling LS at appropriate intervals. Article 358.12 of the NEC outlines the permitted and not permitted uses of EMT. This is crucial for ensuring that EMT is used appropriately for the environmental conditions and intended purpose. Article 358.20 covers the installation requirements for EMT, including how it should be installed as a complete system. This means that all components, such as couplings, connectors, and supports, must be properly installed to maintain the integrity of the raceway. Article 358.22 details the securing and supporting requirements for EMT, which is directly related to the 10-foot rule mentioned earlier. It emphasizes the importance of proper support to prevent sagging or displacement of the conduit. Article 358.24 addresses the bending requirements for EMT, which can affect the pulling tension. Bends reduce the allowable run length without a pulling point. Article 358.26 discusses the number of conductors allowed in EMT to prevent overcrowding, which can increase pulling tension. Article 358.28 addresses the reaming and threading of EMT, emphasizing the need to remove rough edges to protect conductors. Article 358.30 outlines the couplings and connectors that are permitted for use with EMT, ensuring a secure and reliable connection. Article 358.42 covers the grounding requirements for EMT to ensure electrical safety and prevent hazards. Article 314.16 provides guidelines on the required size of pull boxes based on the conduit size and the number of conductors to ensure adequate space for pulling and splicing wires. Article 314.17 specifies the types of boxes and fittings that can be used with the EMT, ensuring compatibility and safety. Article 314.22 addresses the position of boxes and conduit fittings, which can affect the ease of wire pulling and access for maintenance. Article 314.23 details the mounting and support requirements for boxes and conduit bodies, ensuring they are securely installed. Article 314.24 covers the depth of outlet boxes, which can impact the available space for conductors and devices. Article 314.25 specifies the covers and canopies for boxes, ensuring they are properly installed to protect the conductors and devices. Article 314.27 addresses the spacing requirements for boxes and conduit bodies, which can affect the accessibility and ease of installation. Article 314.28 outlines the pull and junction box requirements for raceways, which is essential for planning long conduit runs with multiple bends. NEC Chapter 9, Table 1 provides the percentage of conduit fill allowed for different types of conductors and conduit sizes. This table is essential for determining the maximum number of conductors that can be installed in a given conduit size. NEC Chapter 9, Table 4 specifies the dimensions and properties of different types of conduit, including EMT. This table is useful for selecting the appropriate conduit size for a particular application. NEC Chapter 9, Table 5 provides the dimensions and properties of different types of conductors, including their insulation thickness and overall diameter. This table is essential for calculating the conduit fill percentage. NEC Chapter 9, Table 8 provides the number of conductors allowed in different sizes of conduit, based on the conduit fill percentage. This table is a quick reference for determining the maximum number of conductors that can be installed in a given conduit size. NEC Chapter 9, Notes to Tables provides additional information and clarifications on the tables in Chapter 9. These notes are essential for understanding the proper application of the tables. Firstly, consider the type of conductors being used. Different types of conductors have different insulation thicknesses and overall diameters, which can affect the conduit fill percentage. Secondly, calculate the total cross-sectional area of all the conductors that will be installed in a conduit. This calculation should include the insulation thickness of the conductors. Thirdly, determine the allowable conduit fill percentage for the type of conduit being used. The NEC specifies different fill percentages for different types of conduit. Fourthly, calculate the required conduit size based on the total cross-sectional area of the conductors and the allowable conduit fill percentage. Use the tables in NEC Chapter 9 to determine the appropriate conduit size. Fifthly, verify that the selected conduit size is large enough to accommodate the conductors and any necessary fittings, such as couplings and connectors. Firstly, the support requirements for EMT are outlined in NEC Article 358.30. This article specifies the maximum distance between supports for EMT, which is typically 10 feet. Secondly, the support requirements for boxes and conduit bodies are outlined in NEC Article 314.23. This article specifies the types of supports that can be used for boxes and conduit bodies, as well as the spacing requirements for the supports. Thirdly, the support requirements for cable trays are outlined in NEC Article 392.30. This article specifies the types of supports that can be used for cable trays, as well as the spacing requirements for the supports. Fourthly, the support requirements for raceways are outlined in NEC Article 344.30 for rigid metal conduit, Article 352.30 for rigid PVC conduit, and Article 356.30 for liquid-type flexible metal conduit. These articles specify the types of supports that can be used for raceways, as well as the spacing requirements for the supports. The working space requirements around electrical equipment are outlined in NEC Article 110.26. This article specifies the minimum working space required around electrical equipment, such as panel boards, switchboards, and motion control centers. The working space must be sufficient to allow for safe and easy access to the equipment for maintenance and repair. The height of the working space must be at least 6½ feet of the height of the equipment, whichever is greater. The width of the working space must be at least 30 inches or the width of the equipment, whichever is greater. The depth of the working space depends on the voltage of the equipment and the location of any exposed live parts. For equipment operating at 600 volts or less, the depth of the working space must be at least 3 feet if there are no exposed live parts on both sides of the equipment, 4 feet if there are exposed live parts on one side of the equipment, and 4 feet if there are exposed live parts on both sides of the equipment. For equipment operating at more than 600 volts, the depth of the working space must be at least 4 feet if there are no exposed live parts on both sides of the equipment, 5 feet if there are exposed live parts on one side of the equipment, and 6 feet if there are exposed live parts on both sides of the equipment. The working space must be kept clear and unobstructed at all times. There must be no storage of materials or equipment in the working space. The working space must be adequately illuminated. The lighting must be sufficient to allow for safe and easy access to the equipment for maintenance and repair. The working space must be provided with the means of egress. The means of egress must be clear and unobstructed at all times. The means of egress must lead to a safe area outside of the electrical room. The working space must be protected from physical damage. The equipment must be protected from damage from vehicles, equipment, or other objects. The working space must be protected from moisture. The equipment must be protected from moisture from rain, snow, or other sources. The working space must be protected from dust. The equipment must be protected from dust from construction, manufacturing, or other sources. The working space must be protected from vibration. The equipment must be protected from vibration from machinery, equipment, or other sources. Firstly, ensure that the conduit is properly supported according to the NEC requirements. This will help to prevent the conduit from sagging or becoming damaged. Secondly, use a pulling lubricant to reduce friction between the conductors and the conduit. This will make it easier to pull the conductors through the conduit. Thirdly, use a wire pulling machine to pull the conductors through the conduit. This will help to reduce the amount of force required to pull the conductors through the conduit. Fourthly, use a pulling swivel to prevent the conductors from twisting or becoming damaged during the pull. Fifthly, use a pulling eye to attach the conductors to the pulling rope. The pulling eye should be sized appropriately for the size of the conductors. Sixthly, use a pulling sock to protect the conductors from damage during the pull. The pulling sock should be sized appropriately for the size of the conductors. Seventhly, use a pulling grip to grip the conductors during the pull. The pulling grip should be sized appropriately for the size of the conductors. Eighthly, use a pulling head to guide the conductors into the conduit. The pulling head should be sized appropriately for the size of the conduit. Ninthly, use a pulling elbow to change the direction of the pull. The pulling elbow should be sized appropriately for the size of the conduit. Tenthly, use a pulling box to provide access to the conduit for pulling conductors. The pulling box should be sized appropriately for the size of the conduit. Firstly, the type of environment where the EMT is installed. EMT is not suitable for all environments, such as those with corrosive substances or excessive moisture. Secondly, the number and size of conductors that will be installed in the EMT. The EMT must be sized appropriately to accommodate the conductors and any necessary fittings. Thirdly, the length of the EMT run. Long EMT runs may require additional supports to prevent sagging or damage. Fourthly, the number and type of bends in the EMT run. Bends can reduce the pulling tension of the conductors and may require the use of pulling elbows or pulling boxes. Fifthly, the accessibility of the EMT run. EMT runs that are difficult to access may require the use of special tools or techniques. Sixthly, the local electrical codes and regulations. These codes and regulations may specify additional requirements for EMT installations. NEC Article 300.17 Number and size of conductors in raceway dictates that the number and size of conductors in a raceway shall not be more than will permit dissipation of heat and ready installation or withdrawal of conductors without damage to the conductors or to their insulation. Firstly, determine the internal area of the conduit using the dimensions provided in Chapter 9, Table 4 of the NEC. Secondly, determine the cross-sectional area of each conductor, including its insulation, using the dimensions provided in Chapter 9, Table 5 of the NEC. Thirdly, multiply the cross-sectional area of each conductor by the number of conductors of that size and type. Fourthly, sum the total cross-sectional areas of all conductors in the conduit. Fifthly, divide the total cross-sectional area of the conductors by the internal area of the conduit. This will give you the percentage fill of the conduit. Sixthly, compare the percentage fill to the allowable fill percentages specified in Chapter 9, Table 1 of the NEC. For example, if the conduit contains only conductors, the allowable fill percentage is 40%. If the conduit contains both conductors and fixture wires, the allowable fill percentage is 31%. If the calculated percentage fill exceeds the allowable fill percentage, then the conduit is too small and a larger conduit must be used. Several factors can influence the decision to use a pulling L, also known as a pull box or junction box. Firstly, the length of the conduit run is a primary factor. Longer runs accumulate more friction, making wire pulling more difficult. Secondly, the number and degree of bends in the conduit significantly increase friction. More bends and sharper bends require greater pulling force. Thirdly, the size and type of conductors being pulled affect the friction. Larger conductors and conductors with rougher insulation surfaces create more friction. Fourthly, the conduit fill percentage, which is the ratio of the conductor's cross-sectional area to the conduit's cross-sectional area, impacts the ease of pulling. Higher fill percentages increase friction. Fifthly, the presence of any offsets or transitions in the conduit run can add to the difficulty of pulling wires. Sixthly, the experience and skill of the installer play a role. Experienced installers may be able to manage longer and more complex runs without pulling LS. Seventhly, the available pulling equipment, such as wire pulling machines and lubricants, can influence the decision. Chinese letter A ring to the NEC guidelines and local codes provide specific requirements for pull box sizing and placement based on the conduit size and number of conductors. Firstly, the NEC mandates the use of approved pulling compounds or lubricants to reduce friction during wire pulling. These lubricants should be compatible with the conductor insulation and conduit material. Secondly, the NEC specifies minimum bending radii for conductors to prevent damage to the insulation. Exceeding these radii can make pulling more difficult and increase the risk of insulation failure. Thirdly, the NEC requires that all conduit ends be reamed to remove sharp edges and burrs, which can damage conductors during pulling. Fourthly, The NEC specifies the maximum pulling force that can be applied to conductors to prevent damage. Pulling machines should be equipped with force gauges to monitor and limit the pulling force. Fifthly, the NEC requires that conductors be properly supported and secured within the conduit to prevent movement and chafing. Sixthly, the NEC mandates the use of appropriate pulling equipment, such as wire pulling machines, pulling grips, and pulling eyes, to ensure safe and efficient wire pulling. Seventhly, the NEC requires that all wire pulling operations be performed under the supervision of a qualified person.